These next few podcasts will deal with the skin and the integumentary system. And your learning objectives, you should be able to recognize on glass slides and electronic images the main histological features of different regions within the integumentary system. You should be able to describe key features of each region within the dermis and epidermis. You should be able to describe properties of each of the major cell types within the epidermis. You should be able to describe the process of keratinization, and you should be able to recognize and differentiate between major modifications to the integumentary system. The skin is the external covering of the body. It's the largest organ in the body. It makes up about 15 to 20% of the body mass, and there are two major layers to the skin. There's the epidermis and the dermis. The epidermis consists of a keratinized stratified squamous epithelium. The epidermis is derived from ectoderm. It grows continuously, but it is of a constant thickness because that thickness is maintained by a process of desquamination. The dermis consists essentially of dense connective tissue. The dermis provides mechanical support, strength, and thickness for the skin. The dermis itself is derived from mesoderm. And then the hypodermis is the subcutaneous fascia that would be described in gross anatomy. It basically is adipose, surrounded by connective tissue. The hypodermis is deep to the dermis, and it can be fairly substantial if you live in a cold climate, and it can also be fairly substantial in individuals that are overweight. And then, of course, there are epidermal derivatives like hair and hair follicles, nails, sweat glands, and sebaceous glands, and the mammary glands are considered epidermal derivatives. We're not going to talk about the mammary glands in this series of podcasts because we'll talk about them elsewhere in the course. Skin histology can vary with location on the body. We sometimes think about thick skin in the plantar and palmar regions of the body, so like on the soles of the feet or the palms and the hands. We think about thin skin on the abdomen or the back, and thin skin on the scalp. And as you can see in this last image, lots of hair follicles associated with the skin on the scalp. Now, it is interesting, thick skin and thin skin, as used by histologists, are actually anatomically misleading terms. We should only use them to refer to the epidermis, because the thickest portion of the skin, which would be the epidermis plus the dermis, is actually found on the upper back. But the epidermis on the upper back, as histologists would think of it as thin skin. It would look more like this. It would not have this very intense keratinized layer as you'd see on thick skin. Again, the thick skin here describing the thickness of the epidermis. Now, there can be a fair diversity of skin over the body surface. So regions of the skin that have a lot of hair, the scalp, the pubis, the axillary regions, the eyebrow regions. Regions with vellus hair, for example, might be the eyelids, the forehead, earlobes. There are hairless regions of the skin, the glands, the labia, sides of the foot, palms or soles. There are regions of the skin that are very rich in sebaceous glands, especially in the forehead. And then the skin, which consists of the epidermis and dermis, as we've suggested, is thicker on the dorsal surface as compared to the ventral surfaces. So I want to remind you then, thick skin could be due to a heavy stratum corneum, as we've seen on the soles or the palms, or it could be due to a thick dermis, as you might see on the back. Now, the histological layers of the skin, the epidermis, consists of a specialized keratinized stratified squamous epithelium. The dermis has several regions. There's the papillary dermis, reticulodermis, and then hypodermis. We can talk about an epidermal-dermal junction, which consists of interlocking ridges and valleys. This increases surface area of contact for nourishment, for sensation, and for tight binding. And then the hypodermis is often an adipose-rich layer. The image on the left shows what we would consider histologically thin skin, and that the epidermis itself is fairly thin, but there's a fairly substantial dermis. And then the image on the right, we would say histologically is thick skin, because we're describing the epidermis, and the epidermis would go in this region that I'm tracing. And you can see a very intense stratum corneum. These are all dead layers of cells, and we'll talk about this in a little bit. And then you can see the living cell layers in the epidermis, and we'll begin to describe some of these layers in a little bit, but we can talk about stratum basale and stratum spinosum, stratum granulosum, etc. And then the dermis itself, and we'll talk in a few minutes about papillary and reticular dermis. And here is actually a duct of a sweat gland that's coursing up through the dermis, coming into the epidermis, and here you can actually see that duct as it's coursing through the dead layer of cells in the stratum corneum. Perhaps another profile of a duct over here. This is the image we just showed you. I put this on because I want to highlight that we can talk about dermal papillae like this and epidermal ridges like this, and these are interdigitations between the dermis and the epidermis, and it allows the epidermis to be more tightly bound onto the dermis. And if you were to look at this area in the scanning electron microscope, you would see ridges like this. And here we're looking in the layer of the dermis looking up towards the epidermis, and here's a higher magnification of the image. So here we would be looking from the dermis looking up towards the basal lamina if you want, and here would be some ducts of sweat glands, and these protrusions would actually be the epidermal ridges that are coming down into the dermal papillae. Now, the dermis itself consists of two components, a papillary dermis and a reticular dermis. The papillary dermis is the more superficial layer, and as we've suggested, there are dermal papillae that interdigitate with epidermal ridges in the papillary dermis. The reticular dermis is the deeper layer, and it's less cellular. The papillary dermis has a rich capillary bed that tends to run in a horizontal orientation. It's highly cellular. Fibroblasts predominate in the papillary dermis, but you'll see mast cells, lymphocytes, melanocytes, macrophages, and plasma cells in the papillary dermis. There are extracellular fibers in the papillary dermis that consist primarily of collagen type 3 and fairly delicate elastic fibers. And then there's a second, deeper layer of blood vessels that can sometimes be observed in the papillary dermis. As we said, the reticular dermis is a deeper layer. It's less cellular. It consists of a more dense, irregular connective tissue. The extracellular fibers here would be collagen 1 and coarser elastic fibers. Now, these extracellular fibers are arranged in a regular pattern, and they're given the term Langer's lines. And surgical incisions are generally made parallel to Langer's lines, and that allows for healing to occur much faster and much easier if those incisions are made parallel to the way the extracellular fibers run. Not only does the incision heal faster and easier, but there's a less of a likelihood of scarring. Now, the hypodermis is adipose tissue or sometimes fascia that can be bound to bone, and the hypodermis may contain larger blood vessels, and of course it's easy to recognize histologically because there's a lot of adipose in the hypodermis. This is a histological view both of the epidermis. It's a thin layer of the epidermis, so thin skin, so not a lot of stratum corneum. You can see the dermal papillae and the epidermal ridges, and you can see in the papillary layer of the dermis up here thinner collagen type 3 fibers, and this would also have fine elastic fibers, which may not be so easy to visualize on this preparation. But then the reticular layer of the dermis, which is deeper, you can get a sense of the thicker collagen type 1 fibers. The elastic fibers here would be thicker as well. Now, they're not visible on this image because there's not that much of a field of view on the image, but they're also epidermally derived structures that can be down deep in the dermis, and we'll talk about some of these later. But for example, some of the sweat glands can be deep in the dermis, but they are derivatives of the epidermis. This is a transmission electron micrograph. You can note the collagen bundles that are in the dermis, and here's a fibroblast. The epidermis itself consists of 4 or 5 layers of keratinocytes. Keratinocytes, as we'll talk about, is the major cell type in the epidermis. Keratinocytes mature sequentially and move up through the layers of the epidermis, and the keratinocytes turn over completely in about 30 days. Now, the layers of the epidermis, starting from the basal layer, the stratum basale, also called the stratum germinativum, this area has mitotically active stem cells. The stratum spinosum, sometimes called the prickle cell layer, and we'll show you why we say that. These cells have desmosomes that are readily apparent at the light microscopic level. The desmosomes, of course, hold the epithelial cells together. There's a stratum granulosum, where the keratinocytes here have numerous intensely staining granules. The stratum lucidum is limited to some regions of the thick skin in the areas on the palms and soles. The stratum lucidum is considered part of the stratum corneum, and of course the stratum corneum is a dead cell layer. That's the layer of cells that are sloughing off the surface of the skin. And this is just a histological image of thicker skin. So all of this stratum corneum is a dead cell layer, a little bit of the dermis down at the bottom of the field, and then the epidermis itself, and you can begin to see some of the layers in the epidermis, and we'll show you these in a little more detail. The image in the top showing epidermis, and you can see a hair follicle forming off the epidermis. You can see some sebaceous glands here, so all of this would be dermis, and then a little bit higher power view of the epidermis with a little bit of the dermis. You can see stratum corneum here, stratum spinosum like this, stratum basale like this, and a little bit of the papillary dermis. Just the same image as we saw before, but now here a higher magnification. In the epidermis, all of this layer is the stratum spinosum, and look at the way the cells tend to shrink away. You can see these little fine interdigitations between the epithelial cells. These are the desmosomes. When the cells are fixed, the cells pull away from each other, but they stay attached at these desmosomes, and stain just collects in that area. So this is why the area is called stratum spinosum. It looks like the cells are spiny, or as some people say, the prickle cell layer. It's because of these desmosomal structures that one can still see. And then here, the single layer of cells in the stratum basale, and then just a little tiny bit of the dermis below the stratum basale.